Question 18 to finish off the paper. Organic compounds, or think organic, think carbon, have isomers. Same atoms, different arrangements. A straight chain molecule of this formula, so make sure your structure matches this formula, has a carbonyl group, must have a C double bond O. The compound cannot be oxidized by acidified dichromate. If it cannot be oxidized further, then we would anticipate that it is a ketone group, because if it's an aldehyde, that could be oxidized onto a carboxylic acid. Deduce the structural formula for the two possible isomers of this straight chain molecule. So add in a ketone group, a C double bond O. It cannot go on the end because that would make it an aldehyde, so it has to be at least one carbon in. So you could start off with one carbon on this side and then 1, 2, 3 carbons on the other side. That would give you the first isomer. Check that you have 10 hydrogens, check that you have 1 oxygen, check that you have 5 carbons. You do. This gives you 1 mark. Then remove one of the carbons from this side of the chain and add it to this side of the chain, which gives you 2 on this side, 2 on this side. That would be a second isomer. It cannot be this structure here, where you've got one CH3 group before your double bond O, and then a carbon which has got a methyl group on it. This is just because it tells us it's a straight chain molecule. So yes, this is an isomer, but yes, but it cannot be credited because it's not a straight chain, it's a branch chain. Because here you'd have 1, 2, 3, 4 in your main chain, and this would count as a methyl branch. 18b, a tertiary haloalkane with 3 different alkyl groups, R1, 2 and 3. C and then X represents your halogen, undergoes an SN1 mechanism. 2 isomers are formed. State the type of bond fission. Bond fission in nucleophilic substitution is heterolytic, which means one atom takes the 2 electrons and you end up with a structure where you have got different charges on the 2 substances that are produced. This is an AO1 question. Polar protic solvents for an SN1 mechanism. The next question we had not done to the level of detail which was being requested. Okay. Sorry, photocopied that the wrong way around. 18d. Draw the structure of the intermediate. This intermediate is an intermediate formed from the SN1 mechanism. If it's formed from an SN1 mechanism, it means that it must have a carbocation. So the structure that you've got is your R1, your R2 and your R3, and your carbocation is indicated here. That means that you've only got 3 electron domains. So your molecular geometry is going to be based around these 3 electron domains and therefore be trigonal planar. It's not this structure. This is a structure of the substance that's formed at the end of the reaction. It's not the intermediate that's formed in the middle. So that's why this and tetrahedral would not be the correct answer. 18e. Suggest, given a reason, which percentage of each isomer would be obtained from the SN1 reaction. It's approximately 50-50, just because the nucleophile can attack from either side of the carbocation, and therefore 2 possible isomers can form. So it can come in from behind or it can come from in front, and that will give you your 2 isomers. Question 18f was the one I was just referring to. We haven't done this in the level of detail that it requires for the answer. We have not yet done redox, so I'm going to skip that one. Question 19. Reactivity of organic compounds depend on the nature of the positions of the functional groups, and we've got 2 structures there. Deduce, giving reasons, which can show optical activity. Similar question in the multiple choice earlier. So this carbon here has a hydrogen and a hydrogen. This carbon here has a CH3 and a CH3. Because these groups are the same, this is not chiral. Because these 2 groups are the same, this is not chiral. This carbon has a CH3 and a CH3, 2 groups the same, this is not chiral. This carbon has 1, 2, 3, 4 different groups, which means that this carbon here is chiral. So the answer is A, because it has got a chiral carbon. 19b is an AO1 question. Just knowledge, concentrated sulfuric, concentrated nitric acid are both required. C, we're looking at the formation of the NO2 plus ion, and again this is an AO1 question. Sulfuric plus nitric gives me the NO2 plus ion, water, and HSO4 minus. Double check that the atoms that you have on here in the in the quantities match the atoms that you have here in the quantities. 3 hydrogens, an S, O4, an N, O2, and then the other oxygen there. 19D, explain the mechanism of the reaction between 2-bromo-2-methylpropane as some sodium hydroxide using curly arrows. Before you do anything to do with mechanisms that are nucleophilic, you need to make sure that you've figured out if it's an SN1 or an SN2 mechanism, and the way to do that is to draw out the structure that you are doing the nucleophilic substitution upon. So here we have got the structure. We can recognise that it's a tertiary structure. Because it's a tertiary structure, it's going to be an SN1 mechanism. As it's an SN1 mechanism, but it is a 4-mark question, if you were to do the correct SN2 mechanism, the examiners would credit you with 2 marks if you were completely correct, which is 50% of the maximum marks for the question. That is good, because at least you're not losing marks. You are showing that you do understand how the mechanisms work, but you have to get the right mechanism if you want to get full marks. And I can't state that this is true on every IB question paper that I've seen. The marking points here are always the same. So if you look at the equation that I've got, so stage 1, stage 2, which is your intermediate, and then stage 3, which is your product, the first mark comes from the arrow from the bond to the bromine. If your bond is coming from your carbon to the bromine, you won't get the marks. If it's coming from the bromine to the bromine, you won't get the marks. So from the bond to the bromine will give you 1 mark. Where the arrow starts and where that arrow ends is important. The second mark comes from having the carbocation. The third mark will come from having a curly arrow from the lone pair of the OH to the positive charge. If this is coming from here, you would not get the mark. They would credit you if you took it from the negative charge to the positive charge, but what we're actually looking for is these electrons, this electron motion. So this is the best way, well, this actually is the best way for indicating an OH minus ion, because that's where the negative charge resides. So this would be a perfect way to get both of those marks. And then the last mark comes from 2 points. You have to have your product correct, and then you also have to have a bromine ion being released. Now if you've written NABR, they may not give you the marks for that. Again, it depends on the question. Sometimes they will, sometimes they won't, but writing bromine will always get you the marks, because the mechanism is about the things that are actually involved in the reaction. And sodium, if you're adding sodium hydroxide, the Na isn't involved in the reaction. It's a spectator ion in some ways. It's just there associated with the OH, and then it's there associated with the Br, which yes, technically you have got an alteration in the bonding, but it's not involved in the main part of the main product that we're actually looking at. The other thing is, a few students sometimes will just flip between bromines and chlorines because they're used to doing questions with both, and so get confused. So if you were to write a Cl here, again you would lose the marks. And that is all.